Hey guys, in this video we're gonna solve the fundamental theorem of arithmetic. This is the topic of number theory. So, what is its statement? Its statement is every positive integer means n greater than 1 can be expressed as a product of prime numbers in a unique way. Okay, what does its statements mean? Every positive integer n greater than 1 can be expressed as a product of prime numbers in a unique way. So except for the order of multiplication. इसका मतलब we एक एग्जाम्पल से समझते हैं. सपोज एग्जाम्पल 30. Okay, this is a prime number or composite number. This is a composite number. Okay, let's take 2. 2 is a prime number. 3 is a prime number. 5 is a prime number. 7 is a prime number. But what if I say 30? 30 is not a prime number, but it can be expressed as a product of prime numbers. How? If we take if we see the multiples of 30, we have 2 into 3 into 2 into 3, that is 6 into 5. Okay, 3 5s are 15 and 2 is 30. Okay, this can be written as, like, someone will say, no, I'm gonna start with 3, then 3 into 5 into 2. Then again a person will say ki, no, I'm gonna start with this 5 into 2 into 3. Like it this orders of multiplication can be like 1, can be 2, 3 or many more, but the product of primes are unique. Like you will only get this 5, 2 and 3, 2, 3 and 5 in each and every way. So this is the unique way. So here it is what saying every positive integer n greater than 1 can be expressed as a product of prime, and these all are prime numbers, isn't it? Now if someone will ask me, like, find the prime factorize this 12, let's say 12. Now someone will say that 2 into 4 into 3, I'm sorry, 4 2s are 8, so this is not gonna work. 2 into 2 into 3. Okay, so this is also 2 2s are 4, 4 2s are 12. All are prime numbers. These all are the product of primes. Think of any number possible. 25, it is 5 into 5, which is prime. 36, let's say 36 can be broken down into 6 into 6, right? If someone will say it is 6 into 6, but 6 is not a prime number. But this 6 can be further factorized, like 3 into 2 into 2 into 3. These all are product of primes, right? Multiply this, you will get 36. 3 to the 6. 6 to the 12 and 12 3 to 36. Think of any biggest number possible. You will end up having all the numbers will be the product of prime numbers. Okay. So its explanation is this: every positive integer n greater than 1 can be expressed as a product of prime numbers in a unique way. Here you can also add except for the order of multiplication. Okay, so ये हुआ statement की बात. Now come to the proof. We will gonna prove this. Like how you gonna express to the examiner in the examination. So you have to first write, you will exclude this part. This is just for the explanation. You're gonna only write the statement first and then proof. Okay, proof let n greater than 1 be an integer. Yeah, you have to write this. If n is a prime number, we have nothing to do. We have nothing to worry or nothing to do, because we got the prime number. If n is prime number, there is no further steps, like if n is 2, 3, 5, 7, 13. Okay, there are no further steps. But what if n is a composite number? Then there exists a prime p1 such that n is equal to pn1 for some integer n, n1. Okay, now what does this mean? So if n is a prime number, if you are given with a prime number, then there is no worry, there is nothing to do. But what if n is a composite number? Then we are assuming there will be one integer existing, let's say p1, where n is equal to p into n1 for some integer n1. Okay, n1 is a prime. Here n1 is a prime. Then if n1 is a prime, p1 is also we are taking as a prime. This is going to be p1. P1 is also prime, n1 is also prime. Then n is expressed as the product of prime. Okay, n is expressed as a product of prime because both the numbers are prime. Here there should be no doubt. Okay, for some integer n1, after this you can write here, if n1 is a prime, then n is expressed as the product of prime factors. Okay, but what if this n1 is not a prime number? If this n1 is a composite number, जैसे कि we have seen in this case, what if this 12 would be written like 3 into 4? This 4 is not a prime number, right? So what if we get a number which is composite? So let's assume n1 is if n1 is a prime, then it's expressed as a product of prime factors. But if n1 is a composite number, then what happens? There exists a prime p2, let's say p2, such that n equal to p1 n1. This was in previous case. Now p1 p2 n2 for some integer n2. Okay, integer sign is this for some integer n2. This should be clear till here. ठीक है ना? ये बहुत ही बेसिक सा चीज़ है, जो हमने आपको इधर समझाया ना, उसको आपको वर्डिंग्स में लिखना है. ठीक है, और ये चीज़ अब जब तक नहीं समझोगी, दिस इज़ नॉट गोना हैपन. आपके एग्जामिनेशन में आपको इस तरह से ही लिखना है. ठीक है, सो हमें क्या मिला प्रीवियस स्टेप से? n is equal to p1 p2 n2. Okay, for some integer n2. Now if this n2 is a prime, then n is expressed as the product of prime factor. Okay, if n2 is prime, then n is expressed as a product of prime factors, right? But what happens if this n2 is composite? Here comes the next move. What if this n2 is composite number? Then we continue the process. The process will not gonna stop until we get all the product of prime factors. Okay, what if n2 is a composite number, then we continue the process. Since n is greater than n1 is greater than n2, so this process cannot continue infinitely. Okay, because there will be some number, we will get the number smaller than because prime factors will become smaller than smaller. Okay, so therefore after a finite step we will get some value of the smallest prime factor. Think of the largest number possible. No, we cannot find the prime factors of that largest number right now, but let think of the number 100. Now 100, if we take this, if we start from, now someone will say ki 100 can be written like 10 into 10. 10 cross 10 is 100. But 10 cross 10 is not a prime. We have to express in the product of prime numbers. But 10 cross 10 is not a prime number. So it can be further written like 2 into 5. This can be written like 2 into 5. Now all the numbers are prime, right? All the numbers. Think of 1,000. Okay, 1,000 if you are thinking of. Now the steps will continue to go. Okay, now where was we? Since n is greater than n1 is greater than n2, yes, the process cannot continue infinitely. Therefore after finite numbers, a number of steps, we get n equal to p1 p2 till pk, where all pi's, I means here integer, all pi's are prime. Okay, दिखने में ये इतना बड़ा लग रहा है लेकिन है कुछ नहीं. दिस इज वेरी इजी. प्लीज नोट इट डाउन. और इसका जो एग्जाम्पल था ना उसी के बेस्ड ही. इफ यू वांट मी टू प्रूव द यूनिकनेस, okay, I'm going to solve the uniqueness. Like in the explanation we have mentioned that this can be expressed in a unique way, so that we're gonna solve in the next video. Okay, thank you.